Hey, what's going on guys? Tanmay for Simple Snippets and welcome back to another video tutorial under operational research, especially the linear programming problems part. So in the previous video of this entire playlist, we saw a LPP problem wherein we actually had to formulate the problem and then graphically solve the problem using the graphical solution itself. And it was a maximization problem. So this is an example 2 of the same case. So it's similar to the problem that we saw in the previous video. However, we are going to go a little bit faster compared to that because in that video, it was the first time that we were using Graphical Solution. But now that we have a little bit of understanding of what is Graphical Solution, in this video, we'll go a little bit faster. So with that being said, let's start off with understanding the question first. So let me just read out the question. A toy manufacturer produces dolls and guns for which he requires material and labor. So we have a toy manufacturer and he is producing dolls and guns, and for that he requires two raw materials, that is the actual material and the labor. Now there are certain constraints which are directly given over here. So there are 5 constraints. So let me just read out the constraints quickly. So he cannot produce more than 6 dolls and 5 guns per day. So this is a limit. He must use minimum of 3 hours of labor per day. So minimum he has to use 3 hours. It can exceed more than 3 hours, but the constraint is that he has to use minimum 3 hours of labor. So the manufacturer has to use 3 hours of labor. Next is raw materials are available at most 60 units per day. So the raw materials, that is the second part used to make these dolls and guns, has a limit of 60 units per day. 2 hours of labor is required for each doll and each gun. Raw materials required for each doll and gun are 7 units and 9 units respectively. And the profit per doll is rupees 130 and per gun is rupees 60. Now we have to maximize the profit by formulating and solving the LPP graphically. So our end goal is to maximize the profit because the toy manufacturer wants to make huge profit and he wants to know how many quantities of dolls and guns he should produce per day, which will give him maximum profit. So this is our end goal, right? So let's start off with formulating the table. So we have to first formulate or convert this word problem into an LPP problem. So that's what is called as formulating the LPP. So let's do that. Okay, so using all these constraints, we have made the table. Let me just go through it. So we have 2 toys, which is dolls and guns. To make these dolls and guns, we require 2 things. One is raw material and second is labor, right? And we have certain restriction on the raw materials as well as the labor. So that is why we have third column of availability. So going to the first row, for raw materials, one doll requires 7 units of raw materials. You can see in the constraint number 5, raw material required for each doll and gun is 7 and 9, right? So 7 units required for doll, 9 units required for gun, and the total availability cannot exceed 60. So this is given over here. Point number 3. Moving on for the labor, you can see 2 hours of labor is required for each doll and each gun. So 2 hours over here, 2 hours over here, and what is said is he must use minimum of 3 hours of labor per day. So minimum is 3, it can always exceed. So we'll see how that constraint looks when we actually list down the constraints as well. And there is again a limitation on dolls and guns also. So we have listed it over here that he cannot produce more than 6 dolls and 5 guns. So maximum products that he can make for dolls is 6 units and for gun is 5. And lastly, the profit statement is per doll the profit is 130 rupees and per gun the profit is 60 rupees. So this is that entire table formulation. I hope you've understood it. Now moving on to the next thing, that we have to make certain assumptions, and the assumption is the quantity of dolls and guns. So let me just show you the assumption. Okay, so here's the assumption. Let's assume X and Y be the amount of dolls and guns to be manufactured respectively. So X is the number of dolls and Y is the number of guns, which will give the manufacturer the highest profit. Okay, so this is the quantity X and Y. Remember this, that X represents dolls and Y represents guns. Now, after making these assumptions, we can now convert these constraints into an algebraic form. So let's get to that. And before that, we also have the maximization equation. So what do we want to maximize? We want to maximize the profit, right? And the profit will be given by Z or Z equal to 130x plus 60y. So why 130? Because profit on one doll is 130 rupees and X is the quantity of dolls. So 130 into X will give us total profit on the number of dolls, plus 60y because 60 is the profit made on one gun. So 60 multiplied by the number of guns, which is Y we have assumed over here, will give us the total profit on guns, and when we add up that total, we will get the actual profit. So this is that maximization equation, which is very important, and it is subject to certain constraints. So these are those constraints which we see in the table converted into algebraic form. So the first one is 2x plus 2y greater than equal to 3. So this constraint is actually for the second row, for the labor thing. So 2 corresponds to the labor required, and x is the quantity of dolls. That would give the total labor for dolls. Similarly, 2 into the quantity of guns will give us the total labor which goes into manufacturing guns. And that has to be 3 or greater than 3. So that's why the greater than equal to sign, right? That is the condition that he must use minimum of 3 hours of labor, right? So that's why greater than equal to 3. So this is the first constraint in the algebraic form. The second constraint is for raw materials, that is 7x plus 9y has to be less than equal to 60. So 7 is the units of raw material required to make one doll. So when we multiply 7 into number of dolls, that is x, what we've assumed, we get 7x plus 9y will give us the total raw material, and that total raw material has to be less than 60 because that is our limit. So that's why less than equal to. And lastly, we have x less than equal to 6. So x is the number of dolls, right? Let's assume x and y be the amount of dolls and guns. This is what the assumption is. So x is the number of dolls, that has to be less than equal to 6 because that's the first constraint. He cannot produce more than 6 dolls and 5 guns. So y is the number of guns, so y has to be less than 5. So these are the 4 constraints. So this is the entire formulation of LPP, that is conversion of this entire word problem into a LPP problem. And now we can go ahead and start off with the graphical solution. So let's start off with graphical solution, and the step number 1 is to convert all these inequalities into equations. So we just have to remove all these less than and greater than equal to signs, and we only should have equal to signs. So let's do that. Okay, so step number 1, replace all inequalities in constraints with equalities. So we just removed the less than and greater than equal to signs, and we are left with 4 equations. Now step number 2 is to actually find out the coordinates which we are going to be mapping on the graph. So let's do that. So yeah, step 2, finding coordinates from all the equations to plot lines on the graph chart using assumptions. So for first equation, we are going to be making 2 assumptions. So this is the first equation, 2x plus 2y equals to 3. In the first assumption, we are going to say let x equals to 0. So if x is going to be 0, this part becomes 0, right? So we have 2y equals to 3. So we have y is equal to 3 by 2, which is equal to 1.5, right? So ultimately we have x as 0, what we've assumed, and y as 1.5. So this is what we are supposed to do, that we have to find 2 coordinates for each equation because we need 2 coordinates to plot a line, right? So that's why we are making 2 assumptions. So in the second assumption for the same equation, we are assuming let y equals to 0. So this time this part becomes 0. So we have 2x equals to 3 and x would be 3 by 2. So again x would be 1.5. So this time it is 1.5 comma 0 because this time y we've assumed 0. So the first coordinate is x coordinate, second is y coordinate. So similarly for equation 2 we'll do the same. So I'm not gonna waste a lot of time. I'll just directly show you the equation and then the coordinates. Okay, so these are the values for the second equation, that is 7x plus 9y. So the first xy coordinate is 0, 6.67. Don't get worried about the decimal points. We can easily plot these decimal points also on the chart. We just need to approximate a little bit. And the second coordinate is 8.57, 0. Okay. And for the third and fourth equation, that is x equals to 6 and y equals to 5. Here what happens is this is a special line on the graph. And when we say x equals to 6, it means that it is a line which is perpendicular to the x-axis and parallel to the y-axis, and it passes through the coordinate of x equals to 6. So it's a straight line, which is a straight vertical line on the x-axis which passes through the coordinate 6, 0. So you'll see that in the graph. So you cannot actually have a point over here. You cannot say 6, 0. It is actually a line, but it passes through this point, and it is a perpendicular line to the x-axis and parallel to the y-axis. Similarly, when we talk about y equals to 5, so it's a perpendicular line to the y-axis and parallel to the x-axis, and it passes through 0, 5. Okay, so you'll see that in the graph in a minute. So now that we've plotted all the points, let's actually plot the lines on the graph. So that's the next step, or step number 3. Okay, so let's start off with the first line, that is 2x plus 2y equals to 3. That is this first equation. So we have our graph on the right. The first coordinate is 0, 1.5. So 0 on the x-axis, 1.5 on the y-axis, so somewhere over here. The second coordinate is 1.5, 0. So 1.5 on the x-axis, 0 on the y-axis, so we don't go up. So somewhere over here. And this is going to be our line number 1. So this is 2x plus 2y is equal to 3. So this is our first line. Let's plot the second line. The second line is 7x plus 9y equals to 60. The first coordinate is 0, 6.67. So 0 on the x-axis, 6.67 is somewhere over here. The next coordinate is 8.57 and 0. So 8.57 on the x-axis would be somewhere over here, and 0 means we don't go up. Also this is the x-axis and this is the y-axis. So I forgot to mention that. So plotting this line, it would be something like this. So this is that 7x plus 9y is equal to 60. Okay. Now let's talk about line number 3. That is x equals to 6. So as I mentioned, it is a perpendicular line to the x-axis which passes through x coordinate as 6 and y coordinate as 0. And it is parallel to the y-axis. So it would be something like this. Right? You can see it is parallel. So the y-axis and this line is never going to meet. And it is 90 degree perpendicular to the x-axis. So this line is x equals to 6. Similarly, we have y equals to 5. So it would have 0, 5. So starting from 0 and going up to 5. So it's a parallel line to the x-axis and it is perpendicular to the y-axis. So let me just mark that with some other color. So this is y equals to 5. Okay, so we have actually plotted all the lines, and the next step is to actually mark the feasible region. Now when it comes to maximization, the feasible region is always on the positive end. Okay, and it is only bounded by these lines. So you can see that there is a shape which is created by these lines inside this positive area, that is the positive side of the graph. So this is basically our entire feasible region. Okay, so let me just mark it nicely. Okay, so this entire marked area is our actual feasible region. Now feasible region is such region that any point inside that region will satisfy all these constraints and will also be applicable in our maximization equation, that is that Z equation. However, whenever we consider a maximization problem, the maximum profit or the maximum value of x and y can be earned only at the extremities, that is the extreme ends where lines meet. Okay, so these are those extreme ends. So let me just mark them with white circles. So whenever you are dealing with maximization problems, the maximum profit will be achieved only at one of these points, or maybe there would be 2 points which will have same profit. So ultimately these are x and y values, right? And we know that x is the quantity of dolls, y is the quantity of guns, right? So what we've plotted is the quantities of x and y, and these dots represent those quantities which can yield the maximum profit. So we have to find out the value of x and y of all these points, and then we have to substitute these x and y in that z equation to see which of the point gives us maximum profit. So that's the whole idea. Now let me just name all these points first. So I'll name this one as A, this one as B, this one as C, this one as D, this one as E, and this one as F. Now you have to find out the Z value, that is the maximum profit value on all these points, right? So let me just show you the table, and this is that table that I'm talking about. So the extreme points are A, B, C, D, E, and F. So we have A, B, C, D, E, and F, right? And the maximization equation is max, which is Z equals to 130x plus 60y, right? So this is that equation we have to maximize. Now looking at these points, we already know coordinate points of A, B, E, and F. So A is, you can see, 1.5, 0, because this is some point which we already know, right? This is that point, this one. Similarly for coordinate B, we already know this point because it is passing through 6, 0, right? So we have 6, 0 already. Similarly, E is passing through 0, 5, which is this point through which that Y line is passing, Y equals to 5 line. And we know the F point, which is 0, 1.5, which is this point. But we don't know C and D, right? Because these points are where two lines meet on the graph, right? So in order to find these two lines, we have to use something known as simultaneous equation, and we have to solve two line equations simultaneously to get the value of D and C. So this is an algebraic operation which is used to solve two equations simultaneously to get the value of x and y. So let's do that, and let's get the value of C and D first, and then we'll substitute all these values in the maximization equation and we'll find out which one has the maximum value. So to find out the coordinate C, we have to find out which two lines meet at this coordinate. So we can see from the graph that 7x plus 9y and x equals to 6 are the two lines which meet at this point, right? So now using these two equations, we can say that x is already equals to 6. So we can substitute x as 6 in this equation 1. So 7 into 6 would be 42 plus 9y is equal to 60. So 9y is gonna be 60 minus 42 and 9y is gonna be 18. So y is gonna be 2. So we already got the coordinate, that is x equals to 6 and y equals to 2. So I'm gonna write it over here, 6, 2. So this is how you solve two equations simultaneously to get the values. Similarly, for coordinate D, we have 7x plus 9y, that is this blue line, and the orange line, which is y equals to 5. So now I substitute y equals to 5 in this equation 1. So 7x plus 9 into 5 is 45 is equal to 60. 7x is equal to 60 minus 45. So 7x would be 15 and x would be 15 by 7. So you don't have to divide it, you can keep it as it is. So here we got x as 15 by 7 and y is 5. So I'm just gonna write it 15 by 7 comma 5. And now we have all the values of all the extreme coordinates. So now we can substitute these values in the maximization equation. So the maximization equation is z equals to 130x plus 60y. So 130 is the profit made on one doll. So 130 into the number of dolls plus 60 is the profit made on one gun. So 60 into y, which is the number of guns that are produced. So these 1.5 and 0 are the values of dolls and guns, right? So x represents dolls, y represents guns. So this is x comma y. So substituting this 1.5 and 0 in the equation, so 130 into 1.5 will give you 195 plus 60 into y is 0, right? So we don't need to care about that. So 195 is the actual answer. Similarly, when we substitute 6 and 0, so we have 130 into 6, that would give you 780, and 0 into 60 will give you 0. So this part doesn't count. Again 6 comma 2 is substituted. So we have 130 into 6, which is 780 plus 60 into 2, which is 120. So this ultimately gives us the total of 900. So I'm gonna write 900 over here. Substituting 15 by 7 and 5 in this equation, we get the value of 579. Substituting 0 comma 5, we get the value of 300. And substituting 0 and 1.5, we get the value of 90. So observing this entire table, you can say that when the value of x and y is 6 comma 2, you get the maximum profit of 900, right? So this is that maximum profit area. So now we have reached our final answer, that is the maximum profit that can be earned is rupees 900 when the toy maker makes 6 dolls, because 6 or the x coordinate represents dolls, that is number of dolls, and 2 guns. So this is actually going to be the final answer to your entire problem, and we've reached our final answer, that is maximum profit of 900 rupees, which is obtained when the toy maker makes 6 dolls and 2 guns. So yes, that's it for this video guys. I hope you've understood how to perform maximization using the graphical method. And if you like this video, please give it a thumbs up. Let me know in the comments how this video was. Do share it with your friends, and if you haven't yet subscribed on this channel, make sure you subscribe so that you get notified whenever I upload a new video. Thanks for watching. I'll see you guys in the next video. Peace.